All right, hello. In this video, we are going to continue working with plotting SF objects. We've plotted them mostly just the geometry objects, so we just have been getting like maps, but I want to talk about how we could now overlay some attribute onto that map. So at this point, you should have followed through the previous videos. We created an SF object called US underscore SF. Then we imported a COVID data frame and we merged the COVID data frame with the SF object that had all of the US state boundaries. So you should have this data frame COVID underscore US, which is a merger of those two data frames. And this is an SF object itself. We just included additional attributes that weren't in the original SF object. And so let's say we want to plot an attribute. One thing I can do is just use the plot function with the SF package and plot the entire SF object. And what it does is it creates a separate plot for each of the attributes. And I think there's like 17 attributes in this. So it printed 10 of them. And if you want to get all 17 of them, it's telling you could use this argument inside the plot function. But this is not particularly useful. For one thing, the continental US is really small. You can't really see any of the states in there because we're spread out over really the entire northern hemisphere, because Alaska is straddling the date line. So we've got these little islands over here. And as a result, continental US, where most of the states are, is really hard to view any difference between the states. So this is a pretty bad plot to start with, but it's just something you can do if you want to look at all of the attributes at once. But most likely, we're going to want to plot a single attribute. And rather than have me limit the window based on the XLim and YLim features, what I'm going to do is I'm going to filter the entire COVID underscore US data frame. I'm going to just remove Alaska and Hawaii, since those were the states that are really far away from the rest. So that's what this first command is doing here. So this is using the dplyr command filter, and it's going to go in. So we're inputting the COVID underscore US data frame into the filter command, and this is going to keep all of the observations that have a postal code which is not AK or HI. So that's what this exclamation point is before the is dot element. So this means not equal to AK or HI. So it's going to keep all of the states not equal to either one of those two abbreviations. And now what I'm going to do is just create a plot of the attribute for land area. That's what a land is. So how I plot a single attribute is I enter that name of that column in quotes inside of square brackets beside the name of the SF object. So I've got COVID US, that's my SF object, and I want to plot the A land attribute, the land area. And out comes our plot, and we no longer have Alaska and Hawaii on the plot. So we get a nice looking zoomed in plot of the continental US. And this chose like a default color palette, and it shows a default number of breaks and number of colors to use. And so this is just trying to illustrate how to plot an attribute. We could look at the states and we could observe which states are larger than the others. So it's not that surprising that Texas is yellow. It's much bigger than all of the other states. And then we have these really small states in the Northeast, like New Jersey and Delaware and Connecticut and so on. So this is not a very interesting attribute to plot, since we could just look at the states and gather like which states are bigger than the others. But maybe something that might be interesting to think about would be like what proportion of area in that state is water, just to come up with something based on the variables that we have. So we could wrangle the data using the dplyr package. So here I'm going to create a new column, which is called prop water, because this is telling me what proportion of area is water compared to land. So lakes and rivers and whatnot inside of the state. So I'm going to create a new column using the mutate function, which is called prop water. And I'm going to define that column as the value that we get when we take the area that is water and we divide that by the sum of the areas of the land and the water. So this is like more or less the total area of the state on the denominator. And in the numerator, we have the amount of area that's water. So taking that ratio gives me the proportion of all area, which is water. So now we've added that as a new column to COVID_US, and that column is named prop water. So now if I want to plot that attribute, I just do plot COVID_US, and then the attribute name in quotes is prop water, and I can plot this. And here we get a similar looking plot, but now the coloring is telling me which states have the highest proportion of water, which seems to be very clearly Michigan based on this plot. So we can see there's a bunch of relatively dry states, mostly to the west of the Mississippi. And these states that are, on the coast, they tend to have more water. So Michigan is the most. Wisconsin over here also has quite a bit of water. Louisiana and Florida and Maryland and Delaware as well. Okay, so I think one thing that might be problematic about this map is maybe the color palette that we've used, but we'll clean that up in a bit. If we were curious, well, we kind of looked this out. I mean, it looks like Michigan, Wisconsin, Florida, Delaware. These are some of the Massachusetts and Connecticut. These are some of the higher proportion states with water. If we want to find them more carefully, we can do like the dplyr command slice max and take a look at which observations in COVID_US have the highest water proportion. We'll take the 6 biggest ones, and rather than print the full data set out, I just want to look at the name of the state and the proportion of water. So we're not storing this into any data frame. We're just going to display this on screen. And so here we've got the top 6 states: Michigan, Rhode Island, Massachusetts, Florida, and we can see what proportion of that state is that state's area is water. So Michigan is about 41% of its area is water, and that is by far the biggest. Okay, so I think I will stop this video here, but in the next video, what I want to talk about is how we can clean up or change the color palette that's used to shade these states.